Hello, this is Nicholas from Silicon Chip Publications, and I just wanted to go over what's in our latest issue, the September 2025 issue. And you can see here from the cover that we have an article on aerial drones and the latest drone technology and what they're used for and so on. I'm not going to go over that particular article, but we have quite a few other articles. If we have a look at the contents page here, we can see, as well as the article on drones, we have a review of the new microchip PIC programmer debugger, the PIC Kit Basic. We have an article on Home Assistant, which is a home automation software that can run on a computer, including Raspberry Pi. We also have an associated Home Assistant satellite project where you can build a sensor satellite to use with Home Assistant. Then we have the second half of our article on amplifier cooling, which helps to explain how you can improve the cooling of an existing audio amplifier or other similar piece of equipment, and also has some hints if you're designing something like that, how to keep it cool. Then we have a project that goes with that PIC-Kit basic programmer that adds a power supply to it, because that's something that it lacks, power for the target chip. We have a pendant speaker design, which is the first time that we've published a design for our speaker that hangs from the ceiling. That's quite interesting, I think. And then we have the second part of the ducted heat transfer controller project article, which shows how to build and install and set up that device. And the second half of the USB-C power monitor design that again has the construction, and I'll go over some of that. So let's have a look at the first article in the magazine on Home Assistant. Now, this Home Assistant is not the only piece of home automation software out there, but it's probably one of the best. It's open source, it's very flexible, it works with lots of devices, and it has the benefit that you have full control over it. So if you buy a product, a home automation product that relies on a particular manufacturer, then they might decide to discontinue that service, that product, and then you're out of luck. Whereas if you're using Home Assistant running it on a Raspberry Pi, it's under your control. As long as the Raspberry Pi functions, then everything should continue to work, and you don't need internet access, and you can mix and match devices from different vendors. So I think it's a very good way to go about home automation. If you're not aware, that's things like controlling air conditioners, controlling lights, controlling shutters, monitoring temperatures, viewing camera feeds, stuff like that. So this article basically goes through the process of how to install Home Assistant on a Raspberry Pi, what you can do with it, how to set it up. Shows various devices that you can add here. It shows a thermostat and a camera. You can set this up however you want with different devices. It's even logging the temperature. You can see how it's varied over time, and you can turn things on and off, like control a light, switch a relay, things like that. You can also set it up to switch a relay when a temperature gets too high or too low. So there are lots of things you can do with it. And this article explains how. It's a relatively short article, but it's there are two parts. So this is only the first half, and it gets you started with this software on the Raspberry Pi. And then we have this accompanying article. So one of the things you can do with Home Assistant is add these satellites. In this case, we're showing one. It has a temperature sensor. I believe it has a infrared motion sensor. It has a screen that can show the status. It has an LED that can light up. And so, as you can see, the circuit is pretty straightforward, and the board is very simple. It's basically just a Raspberry Pi Pico W, which is a small microcontroller board with a Wi-Fi module on board, and that just connects to the various sensors and screens and so on. And one of the great things about it is you don't have to write any software, because Home Assistant already has the software. In fact, it actually builds custom software to suit your particular setup once you've configured it. So again, a pretty straightforward, simple article, shows you how to put this device together and set it up and use it. And you can use it for actually quite a lot of different applications. You don't have to use the sensors that we're showing as an example, but of course, it's always a good idea to start with what's tested, and then you can extend it from there. So there's some code there that shows you how to add support for all the features of this satellite board into Home Assistant. And it's pretty much plug and play. You just add the scripts we have and it should work. So that's quite a neat little package there. And you can build multiple of these and position them around your home. As long as they can connect to the Wi-Fi network, then you can control them centrally. So pretty handy. Then moving on to the next article is the pendant speaker. And you can see here it's quite a nice looking speaker. It's black, partly because it's painted black, but also partly because it's made from this pot that you can buy, and it comes in black. So it's always nice when you're building a speaker to be able to just buy the cabinet. Of course, there's some assembly required. You can see the drivers here. There's one woofer. The tweeters come in pairs, but you use one tweeter for each speaker. There's also a port. You can see here the responses. You have the option of whether you install the port, which should give better frequency response, better bass, but it's not mandatory. There's also this optional lamp that serves as a protection feature. So basically, if the speaker is overdriven, the lamp will reduce the power that the speaker receives. So you basically can't destroy it by driving it too hard. Very simple crossover. You can see just 3 components plus the connectors. It's so simple you don't even need a proper PCB. You can just do it on this punched laminate board. And here's some photos of the speakers being tested. Yeah, we have instructions on how to build it. Here's the parts list. So it's built into a planter pot, which I believe is made from fiberglass. And not a huge parts list there, so it's not terribly expensive or difficult to source the parts. So quite a nice little design there if you're into audio. And one of the great things about this is that it can be used in outdoor spaces. You can hang it from the ceiling of a deck or something like that. And it'll sound pretty decent, especially if you add a subwoofer. So probably not quite as good as a proper hi-fi speaker, but much better than a lot of ceiling or outdoor speakers that you can buy. And moving on to the next article, we have our second part of the article on cooling audio amplifiers. And this is quite interesting, I think, because it goes over a specific case of this amplifier here, which is a commercial unit that was found to be running very hot. It was mainly just specific components that are very hot. You can see in this thermal image here that some devices are much hotter than others. And he basically goes through the process of how he figured out what he had to do to modify it, to add baffles, and you can see some of the baffles being tested here to redirect airflow, see where the airflow is actually going in the device. Also some advice on how to run high power tests on amplifiers. Obviously, you don't want to run several 100-watt tests continuously with speakers because you'll go deaf and your neighbors will call the police. So here are some ideas of using resistors instead of speakers, so you can still do a realistic test under load of the amplifier. And then he shows here the final result. He's added these baffles, and without having to, basically only cost a few dollars for the materials and a bit of testing, and he has the whole thing running much cooler. So pretty handy little instructional article there. And then moving on to the last one I'll talk about, not necessarily the last one in the magazine, but this is the second part of the USB-C power monitor that I mentioned last month. And in this case, the second article mainly concentrates on building it and testing it, setting it up. So here it shows it's built on 2 boards. So there's this black board which has the control electronics that also forms the front panel, and then this thin green board that basically just has the input and output connectors and some connects a ribbon cable. So if you don't remember from last month, the idea is that this plugs in line with a USB-C device, and it monitors the voltage and current and power and energy, and lets you basically tell how much power a device is either consuming or being charged with. So a pretty handy device. And so building this board here is pretty straightforward. As you can see from these connectors here, the pins are pretty fine on those. So a little bit tricky to solder, but definitely doable by hand. And once you have those 2 connectors on there, that's the hard bit done. And then you build this board here. We have here, this shows where all the components go, what their values are, so on. The screen is mounted in a slightly unusual way because it's mounted on the back of the board to shine through the hole in the front, but it's not too difficult to do. And then you can see here how the ribbon cable that we supply in the kit connects the 2 boards together, and then there's space for a lithium polymer battery in between that powers the whole thing. Now, yes, it could be powered from USB, but that would affect the readings, and it would also potentially cause problems with certain devices. So it's just easier to power it from a battery. And of course, you can charge that battery. There's a separate socket here for charging it, USB socket. But the device will run for several hours off that battery. And this now it shows you the various screens that you can access, the calibration, measurement, different options like the units to show, so on. So goes through the setup and calibration procedures, explains how to use it, and then we're showing here some test jigs that we've made up that you could make too, that just let you very easily probe USB lines to see what's going on. And this is a trigger board that you can buy that can be used to test it, because you can program this to set the voltage and so on, and you can check that the monitor correctly reads the voltage out. So here are the features and specifications of the device. It's a full USB pass-through, has an internal battery, it's pretty small and light, measures up to 60 volts. I don't think USB normally goes that high, but it can go up to at least 24 volts, so it's good that it handles that. Measure up to 5 amps in either direction with 1 milliamp resolution, or better resolution for low currents, which is quite useful because if you want to see the standby current of a device, it may be well under 1 milliamp, so it's good that you can have the resolution to measure down to low values. And it can also accumulate power and energy measurements. And it says here that the battery will gives 20 hours of usage, so that's pretty good. And it won't drain the battery when it's not in use. So nice little project there, and all the assembly instructions are in there. So it's relatively straightforward to build. It's probably not a great first project because of the size of the components being small and fairly tightly packed, but it's certainly not the hardest thing that you could assemble either. There are no QFN or BGA packages or anything like that. In fact, there aren't really any fine pitch devices except for the regulator and this op amp here, and they're not too bad. So very neat little device. We have a kit for it. It's not too expensive. I can't remember the exact price, something like $70. And it has everything except the battery, basically, and the case. So it has the 2 circuit boards, the ribbon cable, and all the stuff that mounts on those boards in the kit. So you don't have to run around to too many different sources to build this. So yeah, quite a nice little project there. And then if we look back over at the contents page, we can see I didn't look at this aerial drones article. It's about 12 pages long. The PIC kit review and the associated power breakout are also in there. Plus we have this ducted heat transfer controller part 2, and also vintage radio, and a circuit notebook, serviceman's log, letters section. So there's quite a bit in this issue of Silicon Chip. It's out on the 1st of September, so check it out. Thank you.